Welcome to another episode of SHENZHEN IO, where we get to watch me program. What exciting adventure awaits us today? Let's find out. Okay, so we did the VR buzzer. Feel the connection and get ahead. Are you lonely? Do you feel isolated and disconnected from the world? Scientists have shown that the lack of real-life ties to others can lead to depression, which in turn can negatively affect performance at work. Don't let the lack of human interaction reduce your effectiveness. Virtual friends from buddy bots are quality friends nearly indistinguishable from real-life people. Our characters are developed by the world's top personality designers and are completely customizable, so whether you want a supportive presence to help you through a difficult time or a flirtatious sidekick to banter with throughout the day, you're covered. Subscriptions are flexible and competitively priced with other bot companion services. Stop being lonely, feel the connection, and become a top contributor to your company's success. Device A227, unknown optimization device. Poseidon 779, a decentralized autonomous corporation, has determined that the thorium mining operations can be optimized by as much as 2.7% by creating a device with certain specifications. The specifications are included in this communique. Please create 50 of these devices and ship them to blah. Payment will be forwarded upon verification of the completed work. What is this? A decentralized autonomous corporation is a company without human involvement. It has money and investors, but it makes decisions for itself on what to do with that money using information from multiple lower-level monitoring and analysis programs. Some of my classmates were studying them when I was at Princeton, but lately the hype died down somewhat. I guess there are still some operating now, maybe even doing well. Why don't we do the job and see what happens? I made a copy of the specifications it sent. It is on your desk. Like how we're working for robots now. It's pretty sweet. Alright. Unknown optimization device. X and Y are simple inputs connected to an unknown device, presumably some type of position sensor. Power is a simple output connected to an unknown device, presumably some type of motor or high-powered switch. Map the XY coordinate from the corresponding power as specified in Poseidon's geometric specifications, which can be found in your manual. Great. Let's open up the wonderful manual. Did I miss it? Must have. Guess we can do a search. Oh, here it is. Poseidon 779. Thorium mining actuator control subsystem. 2A27 geometric specifications. Understand. This is a geometric visualization of state space. The 2A27 actuator control must take a value as shown in specifications dependent on inputs as described. Understand the 0 value in the middle is required so that the actuator avoids the flux point. Act. Create a device that maps the coordinates to the corresponding power value as specified in this geometric visualization. Okay. It's not really too bad. We can just try to solve for x first. So if x is less than 20, it's 30. If x is greater or equal to 20 and less than 60, it's 0. Otherwise, it's 30. And then we'll deal with this later. No problem. Ooh, we get the splitter. Nice. Let's read about this crazy splitter. I've always wanted a splitter. So these are X bus. That's this thing out. Control the world with the expander. So whatever we read becomes write a 3-digit number to any XBus pin to change the state of simple I/O pins. The 3-digit value is written to them as corresponding to the I/O pins 100 on off. Okay, so this is like the tens column. This is the ones column. So here it's like 100 on off because it's 0 1 1. Okay. Read from any Xbox pin to get a 3-digit number that captures the state of the simple I/O pins. The digits of the simple I/O pin is either on or off. So these are pins, huh? I don't even know if we need to use this thing. What is this thing? Is this a bus? No, it's a pin. I really hate how we have only like two pins and like 4 buses. It's so bizarre. What is this thing? Ooh, it's like a bus version only. Can I have a pen version only, please? Okay. So now we just need to move from P0 into X0, move from P1 into X1, and sleep for 1. Alright, so now we have it into X1 and X0, hopefully. Move X0 into ACC, move X1 into ACC, and sleep 1 just to test it out. And oops, I meant to type dat. Okay, so we have 26 from pins from X. Yep, 26 and 32. Okay. So our X is in ACC now. Let's go back to our crazy table. Let's compare. Test if it's less than 20. If it is, move 30 into P1. Otherwise, move 0 into P1. also need to read. I always need to read both, otherwise it slows. So somewhere should be X. See, X is less than 30 or 20. 20? Yeah. Test if less than. Let's reset this and step through it. All right, so X is less than 20. Wait. X is not less than 20. Is X ever less than 20 in here? No, it's not. All right, so we can't test that one. At least not in this run. Now test that it's less than 60. If it is, then move. Move 0 into P1. Okay, well, it's somewhat right. He's probably just wrong because of this stuff right here. That's when Y is between 40 and 80. So Y. Yeah, as soon as Y becomes between 40 and 80, it's going to be messed up. Yep. Okay. So now I just need to handle that, which is when I move 0 and 30 in. So if I'm moving 0, I need to see if it's... Of course, I'm going to run out of instructions because this game is so annoying. Move that into, let's see, test. Test of less than dat is less than. Let's see, what I can do is just say, instead of x1 being y, okay, what I can do is put another dude right here, read x1 here. I'll route that up. So I'll make this x1. I'll move x1, x0 into ACC and move. So I'll test if, so this guy will just be 1 or a 0 if the y coordinate is met. So it's 0 if it's not. So I got test if it's less than, C is less than 80. Yep. And test if it's greater than, greater than or equal to. So I want greater than 39. Okay. So that's a plus. And that's a plus. And then I'm going to move 1 into x1. Otherwise, I'm going to move 0 into x1, and then I'm going to sleep. All right, so basically I'm just testing. Hopefully, let's try this. All right, so I'm going to put a breakpoint there and simulate. Okay. So hopefully, yep, there it goes a 1. And let's put a breakpoint like right here. So that should be a 0. Yep, that's a 0. Okay. Looks like that works as far as I can tell. All right, so now all I got to do is look at the x1 value, which is either a 1 or a 0. In these two cases, the 30 case is good because I don't need to look at that. So it's these two statements right here and right here that need to pay attention to this x1. So let's see if, test if dat is equal to 1. Jump test 1. Okay, so if it's not true that it's greater than 60, jump down here. I'm gonna run out of room again, aren't I? We gotta move 50 in there. And then jump to done. And this needs more test goo. You can't put multiple stuff on one line. Looks like we can just add 50. So wonder if we can do that easier. Just rewriting this goo. Let's see. Okay, if I'm less than 50, or less than, test if you're less than 60, which means want to, if it's true, then I'll move 0, otherwise I'll move 30 into ACC. Then I'll test DAT, and if that is true, then I'll add 50. And then my final step should just be moving ACC into P1. Something like that. Nope. That's step 3. All right, so this is apparently in a 1 spot, so am I less than, so my ACC is 31, so I should be doing a 50. Let's see, we got 31, 48. 31. 31 on the X, which means you're in this one. And then 48 in the Y, which means you're in this one. Why is it? Am I reading this wrong? 48. I don't know. The output is 0. Well, output's 48. As far as I can tell, it's a typo in the manual. So if we look here, there's simple output is 80, which means you're in this crazy zone right here. And right here it's 30, which means you're in this crazy zone. If we see where it's switched, the Y input was 49 right here, which means you're outside the zone, and 50 right here, which means you're inside the zone. So this is wrong right here. This number should be 50. So let's see. This number should be 30 and 49. See, it's still not good. So I'm inside the zone now, but My x is 33, which means I'm definitely here. Oh, I'm not reading this x right here. I'm just treating this all as, I'm making this square like this big, which is not right. I gotta treat this bit differently. Now what I said before, was this still right? I'm in the zone if... Yeah, probably right, because look, I went from 30 to 80 when I went from 49 to 50 on Y. Definitely seems wrong. So this is 80. Unless this one changed. Let's look at this one. 80 and 73. 80, 73. What? Is it 80 exactly? 81 to 73. So yeah, I'm not looking at the X. That's the trouble. So this is right. This is 40. The added complexity, though, is I need to look at the Y also, or the X also. So I might need some more wires. I guess I could make this one bigger. Route that there. Put this here. Okay, so x0 should go to both these x0s now. This x1 will go to this x1. Should be fine. Now let's move. This should be x1. x0 into dat. Let's do that. Should we do that later? No, it should be okay. So here we just want to test dat is less than 80, and then also test that it's greater than 39, and then move 1 into x1. Something like that. Delete this one. Why didn't I get here? It didn't get split, did it? I wonder if you can split it like this. It didn't get split. Annoying. Okay. Let's see. We want to put this one over here to route these pins. Okay, let's see. Move P0 into X0. Move P1 into X. Move P0 into X3. Move P1 into X2. So X, I'll do it the other way, P3. All right, so my X is X2, which goes to X1, so that's still right. My Y is X0, that's still right. And then I want to move it into X3. Put a sleep over here. It's getting closer. Just a little bit off. Okay, so my X is 71. My Y is 57. Okay, that's right here. So we're looking at the X. And we're saying has to be less than 80 and greater than 39. And then the Y has to be less than 80 and greater than 39. And then I'll move 1 into it. Okay, so that got a 1. And then over here, I'm saying, okay, well, it's 71 is the X. 71 means it's in this space here. And if it's a 1, so I'm testing if it's greater than 60. Test if it's less than 60. If it's less than 60, I'm over here, which it wasn't. Now move 0. Otherwise, I'm moving 30 into the ACC. Okay. And then I need to say, oh, then the DAT should have got tested. This should get tested no matter what. And then, yeah. There we go. No problem. Might be cheaper ways to do this, but at least this works. You have a lot of limitations in terms of the pins and the X buses. And unless I'm missing something, I don't see any way around it. Hooray. Task verified complete. Payment en route. What a future we live in, eh? That was cool. Alright, we just served our robot overlords. See you next time on SHENZHEN IO.